Number 5. Alright, I'm going to solve this any route that I want, and I'm going to go ahead and use elimination because I think that will be the quickest way. Now, if this is a negative 12x, I'm going to try to eliminate it. That means I need to try to make this a positive 12x, so they're opposite. So what I'm going to do is I'm like, well, how do I go from a negative 2x to a positive 12x? Because that's what I'm looking for. And the correct answer is I'm going to multiply it by a negative 6. And you'll see what happens. A negative 6 times a negative 2x is going to give me a positive 12x. And I don't have room to write it underneath, so I'm just going to write it down below this one. And it kind of works out well because then all my stuff is lined up. So now a negative 6 times a positive 3y is a negative 18y. And then a negative 6 times a positive 7 is going to give me a negative 42. So I combine all my stuff. Well, check this out. These are opposite, so they cancel out. These are also opposite, so they cancel out. So that means all I'm left with over here is a 0. And then these on this side, 42 minus 42, well, that cancels out. That equals 0 also. So now at the very end of everything, you see that all my variables were eliminated. Additionally, I have what is a true statement at the very end. Okay, 0 equals 0. Well, does 0 equal 0? It does. So because 0 does equal 0, I have a true statement, and I don't have any variables. That means that my answer is infinite solutions. Let me explain what that means. Solutions. All right. So what this means is that if I were to graph it, I don't know what this looks like as a graph, but let's pretend that I was to graph one of them and it looked like this. Okay. Now I'm not saying this is the actual graph. I'm just explaining what it means. So if I graph the first equation, it would look like that. And then if I was to graph the second one, it would land perfectly on it. Okay, so it intersects unlimited amount of time with the first graph. They're both right on top of each other. So that's what infinite solutions looks like on a graph. As far as algebraically, what it means is that I can pick any number I want for x, and I can pick any number I want for y, and I can plug those into the equation, both equations, and both equations will always balance out. Okay, so it's kind of like anything can be an answer to this, basically. And that's number 5.